The demand for housing keeps rising with a growing population in developing countries that lie mostly in hot tropical zones. With the advent of air conditioning, building developers have been ignoring vernacular practices and relying on active mechanical methods to overcome climate-related design deficiencies. According to the International Energy Agency, only about 8% of the 2.8 billion people living in the hottest part of the world own an air conditioner. But as income and living standards improve, this number is expected to rise sharply over the next decades. In the business as usual scenario, electricity demand for cooling is expected to triple by 2050. We can well imagine its impact in terms of capital investment for power plants and the adverse effect of increased energy demand on the global environment. This video is aimed at presenting a logical sequence of actions to be taken to construct the building rightly, thus achieving human comfort without depleting energy resources and adversely impacting the local and global climate. The energy consumption of a typical building is shown here in the form of a pyramid. Our objective is to shrink the area of this pyramid to the extent possible without sacrificing comfort and to recover the incremental investment in a shorter time frame than that of the building's life. The first step concerns behavioral and lifestyle changes. When a building is poorly designed, indoor environment conditions deteriorate and produce discomfort. Human tendency is to try restoring the equilibrium between us and the environment using physiological responses or behavioral actions. Since energy has become affordable and easily available compared to the past, our first reaction to achieving comfort is to switch on a fan or an air conditioner. We, however, have options to adopt some behavioral changes for reducing our dependence on energy-intensive appliances. As we saw in video 1.2, adaptive comfort builds on the principle that we can adapt up to a certain extent to a variety of indoor conditions by taking an active role through behavioral actions in controlling our indoor environment. By doing so, we help to increase the duration of comfort in the year and lower the energy demand. The second step is integrated designing to suit the location. In hot, humid climate, the main objective is to minimize heat gain and maximize heat dissipation in order to create comfortable and healthy living conditions. As we saw in video 1.5, by adopting the basic principles of bioclimatic and passive architecture, it is possible to protect the indoor parameters from the highly fluctuating outdoor climate and reduce the need for active cooling devices. For this, it is important to involve all stakeholders for a holistic and integrated design that minimizes the incremental investment. The third step is energy efficiency and conservation. Once the outdoor heat gain is minimized, the next challenge is to reduce the internal heat gains from the various appliances used indoors by choosing the most efficient ones available in the market. Video 1.6 covered this topic in detail. Efforts should be made to use them only when needed and avoid phantom loads. The first three steps would have helped us in achieving a low energy building. If there is on-site potential for tapping renewable energy like solar or wind to offset the low energy required by the building, one may opt for it on condition of having capacity to invest or having access to financing at reasonable cost. If there is no scope for generating energy on-site, off-site options may be explored, such as district cooling with chilled water network operating with renewable energy or waste heat. Favorable policies in more and more countries are making it possible for building owners to install grid interactive renewable power plants to achieve the status of net zero or energy positive buildings. To conclude, buildings for the future demand that we design our buildings by adopting the least cost path of the energy sustainability pyramid. Future generations of building can aim even higher by conceiving regenerative buildings that promote a sharing economy, net zero energy districts, electric vehicle charging stations, etc.